Good morning, everybody. In previous class, we shall discuss today about the separation the components of a mixture. So sometimes the special techniques are used to separate the components of mixtures like evaporation, centrifugation, decantation, sublimation, centrifugation, chromatography, distillation and fractional distillation. So here today we shall discuss about the chromatography. So what do you mean by chromatography? When chromatography is used. So let us see about that. So here chromatography method is used for separating colored components from a liquid by using a filter paper or blotting paper. Chromatography means this method is used for separating colored components from a liquid by using filter paper or blotting paper. So how the colors will be separated through the filter paper or blotting paper? So let us know through the activity. So take a thin strip of filter paper. Observe this figure. So to easily know how the chromatography will be used and separated the colors. So take a thin strip of filter paper. Draw a line on it using a pencil approximately 3 cm above the lower ledge of the filter paper. Draw a line on it using a pencil approximately 3 cm above the lower edge of the filter paper. Put a small drop of ink. So it's water soluble, that is form a sketch pen or fountain pen. So at the center of the line, let it draw. So lower the filter paper into a glass jar or test tube containing water. Lower the filter paper into a jar or glass or beaker or test tube containing water, so that the drop of ink on the paper is just above the water level. So as shown in the figure. So observe here figure. So here the filter paper are put into the just above the water level and leave it undisturbed for some time. And watch carefully. Water rises on the filter paper and record your observation. What you have to observe? The ink that we use has water as the solvent and the dye is soluble in it. The ink that we use has water as the solvent and the dye is soluble in it. As the water rises on the filter paper, it takes along with it the dye particles. As the water rises on the filter paper, it takes along with it dye particles usually. See, a dye is a mixture of two or more colors. You know that in your previous class. What do you mean by dye? So, a dye is a mixture of two or more colors. So, the color component that is more soluble in water rises faster, and this way the colors get separated. What you call in this process? So in this process, with the process of separation of components of a mixture, it is called it as an chromatography. The process of separation of components of a mixture is known as chromatography. Here in Greek word chromo means color. In Greek word chromo means color. So this technique was first used for separation of colors. So this name was given the chromatography. Chromatography is the technique used for separation of those solutes that dissolved in the same solvent. Chromatography is the technique used for separation of those solutes that dissolved in the same solvent. So with the advertisement in technology, here never techniques of the chromatography have been developed. So you will study about the higher classes, how the separations will be and takes place through the chromatography. So it is used to separate the colors in a dye, and it is used in the pigments from natural colors, and it is also used to the separation of drugs from the blood. So that's why the chromatography it can be used to separate the separation of dyes. So here see that the figure you can easily know that how the separations will be and takes place through the filter paper. With the examples, through the examples, you usually know that how the separation will be and takes place. So once again I repeat it, here chromatography is used for separating colored components from a liquid by using a filter paper or blotting paper. For example, put a drop of ink in a one end of a strip of filter paper and dip the end of the paper in a test tube containing water. Ink is a mixture of two or more colored components. The components which is more soluble in water rises faster and get separated. And then distillation. Here distillation means the method is used for separating a mixture of miscible liquids by boiling the mixture and cooling and condensing the vapors. Distillation method is used for separating a mixture of miscible liquids. Separating a mixture of miscible liquids by boiling the mixture and cooling and condensing the vapors. So let us now through the activity how the miscible liquids are separated by boiling and the mixtures are cooling and condensing the vapors. So here let us try to separate acetone and water from their mixture. So if we used for separating a mixture of two miscible liquids having sufficient difference in their boiling points. Having sufficient difference in their boiling points are used to separate a mixture of two miscible liquids. So for example, so if a mixture of acetone and water is heated in a distillation apparatus. If a mixture of acetone and water is heated in a distillation apparatus, or take the mixture in a distillation flask and fit it with a thermometer as shown in the figure. So dear students, observe the figure carefully. How the apparatus are arranged. So take the mixtures in a distillation flask, fill it with a thermometer and heat the mixtures slowly, keeping a close watch at the thermometer. Heating the mixture slowly. Mixture means here acetone and water are the mixture. So this mixture are heating slowly and close the watch glass at the thermometer. When you heat this acetone vaporizes and condenses in the condenser and be collected from the condenser outlet. So observe this figure. Here acetone are collected to the outlet. Here the acetone, when you heat the mixture, here the acetone are vaporizes. The acetone are vaporizes and condenses in the condenser or collected into the condenser from the outlet, and water is left behind in the distillation flask. And water is left behind in the distillation flask. So simply to say, if a mixture of acetone and water is heated in a distillation, the acetone has lower boiling point than water first boil and cool and condenses and is separated from the water. So that's why the separation of two immiscible liquids by distillation. And then fractional distillation. Dear students, so that figure is very important in your examination. So draw a neat label diagram of fractional distillation. So note down the figure and practice in your home also. So here fractional, you know that the distillation. Here fractional distillations means it is used for separating a mixture of two or more miscible liquids whose difference is boiling point is less than 25 Kelvin. So it is used for separating a mixture of two or more miscible liquids whose difference in boiling points is less than 25 Kelvin. So let us know. So how the fractional distillation will be and takes place. The apparatus is used for smaller fractional distillation is similar to that used for simple distillation. The apparatus is used for fractional distillation is similar to that of the simple distillation, except that a fractionating column is fitted between the distillation flask and condenser. The fractionating column has glass beads which increases the surface for the vapors to cool and condense. The fractionating column has glass beads. Glass beads, observe the figure. In the fractionating column, here the glass beads are there. So these glass beads increases the surface of the vapors to cool and condense. So fractional distillation is used for separating the components of not only the two miscible liquids, it is also used for separating the components of petroleum, separating the different gases from air also. It is also used for the separating the petroleum and separating the different gases from air. And then separation of components of air. So you know that how many percentage of air are present, how many percentage of our air present in the atmosphere? Here 21 percentage of air is present in the atmosphere. So you know that air is a mixture of many gases. So how the components are separated from the air? So let us see about that. So how can we obtain different gases from air? So here air is a homogeneous mixture. Air is a homogeneous mixture and it can be separated into components by fractional distillation. So it can be separated into components by fractional distillation. So let us know the flow diagram step by step. Through the flow diagram, let us now through the step by step. So here air. So when air is compressed, so and cool by increasing the pressure and decreasing the temperature, its form comes into the liquid air. And this liquid air allowed to warm up slowly in fractional distillation and gases get separated at different heights. When air is compressed and cool by increasing pressure and decreasing temperature, so it can be converted into liquid air. and this liquid air allowed to warm up slowly in fractional distillation column and gases get separated at different heights. Here, the boiling points of oxygen is 183, argon is 186 and the nitrogen is 196 are the boiling points. So here, if you want oxygen gas from air, we have to separate out all the other gases present in the air. If you want oxygen gas from air, we have to separate out all the other gases present in the air. The air is compressed by increasing the pressure and is then cooled by decreasing the temperature to get the liquid air. So observe the diagram. When the air is compressed by increasing the pressure and is then cooled by decreasing the temperature, so to get liquid air. So this liquid air is allowed to warm up slowly in fractional distillation column, whereas gases get separated at different heights depending upon their boiling points. So the liquid air is allowed to warm up slowly in a fractional distillation column where gases get separated at different heights depending on their boiling points. So that's why the separation of components of air. And then how can we obtain pure copper sulfate from an impure sample? Do you know how can we obtain the pure copper sulfate from an impure sample? So here, let us now through the activity. So here, take some approximately 5 gram of impure sample of copper sulfate in a china dish. Take some approximately 5 gram of impure sample of copper sulfate in a china dish. Dissolve it in a minimum amount of water. Dissolve it a minimum amount of water and filter the impurities out. Filter the impurities out. Evaporate water from the copper sulfate solution so as to get a saturated solution. Evaporated water from the copper sulfate solution so as to get a saturated solution. And cover the solution with a filter paper and leave it undisturbed at room temperature to cool slowly for a day. So you will obtain the crystals of copper sulfate in the china dish. So this process is called crystallization. Once again I repeat it. When cover the solution with a filter paper and leave it undisturbed at room temperature to cool slowly for a day, you will obtain the crystals of copper sulfate in the china dish. So this process is called crystallization. Here the crystallization is the process of obtaining a pure solid in the form of crystals from its solution. Crystallization is the process of obtaining a pure solid in the form of crystalline from its solution. For example, by crystallization we can obtain pure copper sulfate from its solution. Or the crystallization method is used to purify the solids. So for example, the salt we get from the sea water can have many impurities in it. You know that. Here in the sea water the salt is present. The salt we get from the sea water have many impurities in it. To remove these impurities, the process of crystallization is used. To remove these impurities, the process of crystallization is used. So crystallization is a process that separates a pure solid in the form of its crystals from a solution. Here, crystallization techniques is better than the simple evaporation technique. Note down the point. Crystallization technique is better than the simple evaporation technique, such as some solids decompose or some like sugar may get chilled on heating to dryness. Some impurities may remain dissolved in the solution even after filtration and evaporation. This contaminates the solid. Purification of salt that we get from the seawater. A crystallization method is used to purification of salt that we get from the seawater, and it is also used to separate off crystals of alum or pitchkari from impure samples. Thus, by choosing one of the above methods according to the nature of the components of a mixture, we get a pure substance. So, with advancements in technology, many more methods of separation techniques has been devised to drinking water. So that's why. So, when easily to say here crystallizations means it is the process of obtaining a pure solid in the form of crystals from its solution. For example, the crystallization we can obtain pure copper sulfate from its solution. So dissolve about 5 gram of copper sulfate in minimum amount of water and filter the solution to remove the impurities, and evaporate the solution in a china dish to get a saturated solution. So cover the solution with a filter paper and allow it to cool, and pure copper sulfate crystals are formed. Okay dear students, today we shall discuss about the how can we separate a mixture of two immiscible liquids? Fractional distillation. How can we obtain different gases from air, and how we can obtain the pure copper sulfate from an impure sample. Okay, thank you.